This video covers DOM event model and JavaScript. The structure of this video is as follows. DOM event model, listening for DOM events, DOM event flow, and the summary. Alright, let's get started. DOM event model. The W3C designed the document object model system with two main goals. A. Event system for registration of event listeners and describing event flow through the DOM tree structure. B. Provide a common subset of event systems used in DOM Level 0 browsers. These events and systems are implemented in all modern web browsers, which lets us focus on event-driven programming. The DOM event model covers how DOM events flow through the tree-based DOM structure. The DOM event model also covers how to interact with a set of interfaces to access contextual information on events and how to register event listeners. Document object model events come in many different shapes and sizes. They can be driven by the mouse, by a touch, by the keyboard, and by a few other different types of specific actions. Because various web browsers had significant differences in implementation and what events they responded to, the document object model event model was standardized by the W3C and DOM Level 2. When any kind of one of these events is triggered, we can have our code perform one or many tasks. If we focus only on DOM mouse events for the moment, we can take a look at a few of the common ones. There are many DOM mouse event drivers that are considered mouse events. The main ones are related to clicking and moving the mouse over something. Because browsers can respond to these events, we can write exactly what happens when one of these events occurs. Let's cover these main ones and how they are defined. A mouse click event fires when the mouse button is clicked over an element. A click is defined as a mouse down and mouse up over the same screen location. A mouse double click event fires when the mouse button is double clicked over an element. A click is defined as a mouse down and mouse up over the same screen location. A mouse down event fires when the mouse button is pressed over an element. A mouse up event fires when the mouse button is released over an element. A mouse over event fires when the mouse cursor is moved onto an element. A mouse move event fires when the mouse cursor is moved while over an element. A mouse out event fires when the mouse cursor moves away from the element. If we go back to the list of different types of event drivers, we can see that there are many ways that a user can interact with the web page and thus trigger various events. The rest of this video will focus on how to capture these events and how they flow through the DOM tree. Listening for DOM events. In this example, when the HTML link is clicked, an alert will pop up with the string clicked. This is the simplest way to define an event handler/listener. This is called a DOM Level 0 event listener. While it is the simplest way, it is not recommended for a few reasons. 1. The JavaScript is written as part of the HTML, which violates separation of concerns. 2. This type of code is inflexible because every link will need to have its own written handler, which means you can not assign a handler to all the links. 3. We can only define one type of handler for the link. In this example, when the HTML link is clicked, an alert will pop up with the string cupcake. This is called a DOM Level 1 event listener. This solves the separation of concerns issue. The HTML is written separately from the JavaScript event handler/listener. This allows us to write a function for events, and then we can attach it as many times as we like. It is a little bit more complicated than the previous example as we are setting a callback function as an attribute of the HTML element, which means that if we define a new handler this way for the same element, it will overwrite that attribute. So in the example on the screen, when this link is clicked, the word cupcake will be the alert that comes up, not vanilla. This is because the second time we define the event handler, it overwrites the original event handler. So the main downside to this approach is that we can only define one handler per element. In this example, when the HTML link is clicked, an alert will pop up with the string vanilla. Then when you press OK to that alert, a second alert will pop up with the string cupcake. This is called a DOM Level 2 event listener. This solves the separation of concerns issue. It allows us a great deal more flexibility than defining attributes of the HTML element. It also allows us to attach as many event listeners to a specific element as we want. In this example, we attached 2 event listeners where we could have attached 1 or many more. Looking specifically at the code, let's break it down. First, we have the HTML code for a link. Then we have a section of JavaScript code. In this JavaScript code, we first select the element that we are going to use. We do this by using the HTML element ID. Then we define a function named sayCupcake that evaluates the alert function with the string cupcake. This will cause an alert to pop up in the browser when the sayCupcake function is called. Lastly, we use the addEventListener method to tell the element 3 things. 1. What to listen to, in this case a click event. 2. What to do when the event is heard, in this case call the function sayCupcake. 3. We tell it false. This third parameter is how we tell the event to trigger at a certain point in the flow of the event through the DOM tree. In the next section, we'll explore what false versus true do as the third element of the addEventListener. For now, know that this third parameter is used to tell the event whether the event handler is to be fired on the capture or bubble phase of the DOM event flow. DOM event flow. Looking at the previous example, we can look at the syntax for the addEventListener. The first part of the syntax is the target. This can be a DOM element in the document itself, a window, or any other object that supports events. The type is a string representation of a specific event type to listen for. There are W3C specific events, and then there are browser specific events. So you want to make sure you check carefully that the events you are listening for are supported by all browsers. The listener is the object or JavaScript function that receives a notification that the event of a specific type has occurred. Lastly, the useCapture tells the listener when the user wants to initiate the event trigger. Events flow through the document in 3 phases. The first phase is the capture phase, the second phase is the target phase, and the third phase is the bubble phase. Let's take a look at this example HTML code. This is an HTML document that contains a 2x2 table. There are 2 rows and each row has 2 columns. The TDs are child elements of the TRs. The TRs are child elements of the TBody. The TBody is a child element of the table. The table is a child element of the body, and the body is a child element of the HTML. This picture from the W3C working group perfectly illustrates the DOM tree and the event flow. When a TD element is clicked, the click event drills down the document from the HTML tag to the element clicked and then makes its way back up. The first part is the capture phase where it goes down the tree. The second part is when it interacts with the element that triggered the event. The third part is the bubbling phase where it goes back up the tree. During the capture phase, the event is sent from the root of the tree to the parent of the target node. During the target phase, the event is sent to the target node. During the bubbling phase, the event is sent from the parent of the target node to the root of the tree. When we click on the TD, the DOM calculates that capture phase path. At each element, as the event is sent down, capture phase event handlers will fire in order. So a capture phase event handler will fire for the document, HTML, body, table, TBody, and TR. After the capture phase has completed, the target phase start. This is where the event handler for the element we interacted with will get the event object. After the capture phase and the target phase are done, the bubbling phase will commence. At each element, as the event is sent up, bubbling phase event handlers will fire in order. So a bubbling phase event handler will fire for the TR, TBody, table, body, HTML, and document. As you can tell, it just does the capture phase in reverse order. Alright, so we now understand that when an event is triggered, it goes through the capture phase, target phase, and bubbling phase. Let's take a look at the example on the screen. We have an HTML table with 1 row and 1 column. The TR element has an ID of TR_hello. The TD element has an ID of TD_hello. We use JavaScript to attach event listeners to the TR element and the TD element. We click on the vanilla cupcake link. What happens next? And which alert will show up first, the vanilla alert or the cupcake alert? What order the event listeners/handlers are fired depends on two things. 1. Which element is the parent and which element is the child? 2. Which element is fired during the capture phase versus which element is fired in the bubbling phase? In this example, the TD element will fire first because neither addEventListener had the useCapture set to true, which means that the events will be fired in the bubbling phase. Since the TD is a child element of the TR, it will come first. In this example, both addEventListeners have the useCapture toggled to true, which means both events will be fired during the capture phase, which means that since the TR is a parent of TD, that the TR will fire first. In this example, the TD element will fire first and then the TR element. Why is this? Because the useCapture is toggled to true for the TD element while it is not for the TR element. Lastly, let's explore this just a step further. Given the code on the screen, what's going to be the order of the numbers that are alerted? The answer is 2, 4, 1, and then 3. The 2 shows up first because it is the first defined event listener that had true for its useCapture option toggled. The 4 shows up second because it is the second defined event listener that had true for its useCapture option toggled. The 1 shows up third because it is the first defined event listener that had false for its useCapture option toggled. And the 3 shows up fourth or last because it is the second defined event listener that had false for its useCapture option toggled. This tells us three big things. 1. Event listeners from the capture phase are executed before event listeners from the bubbling phase. 2. Event listeners are executed in order of definition. 3. Capture phase overrides definition order if there are bubbling phase event listeners defined earlier than capture phase event listeners. And with that, we have covered the basics of how DOM events work, how we can add listeners to them, and how we can make sure they execute at the right time. Since there are events that can be driven by the mouse, by a touch, by the keyboard, and other input devices, it is good to read up on the particular event you are adding to your data visualization, which is where our next video will go, how to add events to D3 data visualizations. The summary. This video covered DOM event model, listening for DOM events, DOM event flow, and the summary.